Guys, welcome to YouTube channel Foundation JE. Today in this lecture we will see about logarithm. In this lecture first we see the definition and next we see what does mean by natural logarithm and common logarithm. Okay, and then guys we see what are those conditions for logarithm to be defined. Okay, next guys we will see some important rules which are being followed while solving the logarithm problem, like power rule, product rule, quotient rule, change of base rule, equality rule, number to logarithm power rule, and guys at the end of this video we will see inverse of a function and inverse of a logarithmic function. Okay guys, in this lecture we will also see some mathematical examples based on logarithm too. Okay, so guys now time to see first definition of logarithm. Okay, so see definition here. Now guys, definition here. How many times a number multiplied itself to give an another number is called logarithm of another number. Okay guys, so another number in logarithm is known as argument. Okay guys, before going to explain this definition, first of all you know what does mean by natural logarithm and common logarithm. Okay, so natural logarithm, when ln and whose base is e, then such type of logarithm is known as natural logarithm, and common logarithm when we write here like this one, log and whose base is 10, then this is known as common logarithm. Okay guys, some cases you can see the log base may be 2, 3, 4 and 5, so it is another type of logarithm. Okay, now guys come to our definition. How many times a number multiply itself to give an another number is called logarithm of another number. Okay, suppose guys you take 100 here, okay, and take log whose base is 10 now. Okay, so what we will get, you will get here 2. Okay, so see here this base, okay, which is 10 here, a number now multiply itself 2 times. Okay, so you will get 100. Okay, so this one is here known as argument, and this one in logarithm is known as base, and this one is known as exponent. Okay guys, already we have discussed detail about exponent. So you guys, if you did not see that video, so first see that video whose link is given in the description box, so it is easy for you to understand the logarithm. Okay, now guys, here see, if we write a number like this one, b to power of x equal to here a. Okay, so you guys to find the value of x, so that this equation must be equal to a. Okay guys, I word here equation because here there is a equality sign. Okay, and if we write like this one, okay, so this one is known as expression until unless it is not equate by some number or zero. Okay, so come to our point here, b to power of x equal to a. Okay, if we take a log whose base is b, and this one like this one, or equal to log b and whose argument is a. Okay, so finally later we read about the power rule. You just remember this one, when x is on the power of the argument, then x becomes the coefficient of log, and this one becomes this one. Okay, so you remember this one, log b whose base is also b, then this one equal to 1. Okay, if it is like say 10, or this one also 10, so this value is 1. So you can check a number itself multiplied by itself how many times, 1 times. Here 1 is exponent here, so the final value you will get here 10. Okay, so next one, if this value is 1, so finally you can write x equal to log a and base is b now. So this one finally give you the value of x. Okay, so guys, now time to see some rules are here defined for logarithm. Okay, see, we read just here first one, log whose argument is b and base is also b, then this value is 1. Okay, and the second one, if argument is 1 and whose base is b, okay, b may be any number 1, 2, 10, 5, 1 by 2. Okay, so this value will be 0. Okay, the third one, suppose log, and here x is given and a is a base. Okay, so x must be greater than 0. Okay, so x can be 0.001, 1 by 2, 1, root over 3, and etc. Okay, and it cannot be a negative number. So always 0 greater than x. Okay, So what does mean here? X cannot be minus 1 by 2, minus 0.02 and etc. Okay, and here another rule, x cannot be 0. So if log of a and x here, okay, and x equal to 0, then this is not defined. Okay, so another assumption, a always greater than 0. Okay, so what does mean by here? Means the base must be greater than 0. Okay guys, now suppose here log whose base is c and x minus 2 is given. So we can say x equal to minus 1 or x equal to 2. So our answer is no. Why? Because if we put the value here in argument, so this becomes minus 3 and this becomes here 0. Okay, now we start the rules which are being followed while solving the maths problem. Okay, see one by one. Okay, the first rule is known as a power rule. Okay, so what a power rule says guys, suppose here log whose base is here say c, okay, and the argument is like this one, okay, then its value will be n, will come in coefficient of log here, and we say argument m and this is c. Okay, so this is known as power rule of logarithm. Okay, so see one example for this one. Suppose log whose base is say 3, okay, and here 8 is given like this one. Okay, so you know 8 can be written like 2 into 2 into 2, means we factorize 8. Okay, so we get 2 to power of 3. Okay, so we have already discussed this one in exponent lecture. Okay, the link is given in description box. Okay, now when we put the value of argument, or you can say 8, so you can write like this one. So this becomes 3 log 2 whose base is 3. So this way the power rule work here guys. Okay, the second rule, which is known as product rule. Okay, so product rule, suppose here log whose base is say a and mn is any number which is product of the two numbers. Okay, so we can write it as a log m whose base is again a, then plus sign log n whose base is a. Okay, so you can say sir where we can use such rule. Okay, suppose guys here log whose base is now 3, okay, and 16 is any number. Okay, so we can write it as a log 3 2 into 8. Okay, so this time we can write log 2 whose base is 3 plus log 3 whose argument is 8. Okay, so see this 16 which is now multiple of two number 2 and 8, we can write like this one. Okay, the third rule is known as a quotient rule of logarithm. Okay, so what it say, suppose log whose base is b and m by n. Okay, so this can be written as log m whose base is b minus sign log, okay, and whose base is b, and this is equal to n. Okay, so guys, see one example for this one. Suppose log whose base is now say 10 or another number is 3 by 4. So we can write it as a log 3 whose base is 10 minus log argument 4, and this is here base 10. Okay, so this way it can work. Okay guys, here one thing you notice, where this formula come, you can also use this power rule here. Okay, see here we write log m by n or whose base is b. We can also write guys here log whose base is b, and this is m n or n to power of minus 1. Okay, now you can utilize here the product rule. Okay, so what can we write here? Plus sign log whose base is b n to power of minus 1. Okay, so now guys this becomes log m whose base is b, or you use the power rule. Okay, so this becomes here if we write plus, then the coefficient of log is becomes minus, and this is log n whose base is b. So finally we can write log whose base is b and argument m, then minus log n whose base is again b. So finally see how this one come. Okay, now guys, see the another rule which is known as a change of base rule. Okay, what it say? Okay, fourth one is here change of base rule. Okay, so what it say guys, log, suppose here b is argument or say c is here base. Okay, so we can write it as a log b and here log c, and now you can consider any base. Okay, now say if this is a, then this must be equal to a. Okay, now guys, here we can also write like this one. If this denominator term goes right to left, then it becomes log c whose base is a multiply by log b whose base is c. Okay, so this one equal to log b whose base is a. Okay, in examination guys, there may be one objective question. You can see if here say log of x whose base is a, log y whose base is x, log z whose base is y. So its answer will be guys here log whose base is a and this is z. So you can say, sir, how this is coming? So if we apply for this one a change of base rule, so you can write it as a like this one. Okay, now say if you base is c, then its base is also c into log c whose base and y or log c or x guys. Then again you can write this one log z and log of y whose base is c and c. Now see guys, this one denominator cut the this numerator and this denominator cut the this numerator. Okay, so finally what you get here, log z whose base is c and log here a and whose base is c. So finally what we know, this is equal to log z by a. So in this way the change of base rule work guys, or you can see such questions in exam. Okay, so you remember this fact also. Okay, the next one guys, say fifth one, which is known as a equality rule. Okay, of logarithm. So what it say, suppose log whose base is say b and x is argument, and again log whose base is b and this one equal to y argument. So if both are equal, then x must be equal to y. Okay, so this is known as a equality rule of logarithm. Okay, the sixth one guys, see here, number 2 logarithm number. Okay, what does mean by this one? Suppose a is base, now its exponent or power you can say is log x whose base is a, then this is equal to guys x. Okay, so you can say sir how you can write this one. Okay, suppose guys this one. Okay, now take a log whose base is again a and this is log a x. Okay, now if we write like this one, this is now becomes a power. Okay, or now this is like this one, so we can write this power in coefficient now by using a power rule. Okay, so this one becomes this one, so finally this value is 1. So see, this is equal to log of ax. Okay, now this one becomes a RHS side. Okay, so this way you can use this formula. Okay, now guys, some another rule which is also important here. See, log, suppose here a is any number whose power is m and here base is also say c which power is n. Okay, so this one guys equal to what here? Okay, we can write it as a m for this one power rule, then this becomes guys log a whose base is c to power of n. Okay, so further we can write here n is now come in numerator, or this is equal to a and c. So basically here n is multiplied by 1 by n or m. Here already m is given, so we write it as m by n. Okay, so this way we can use this rule. Okay guys, in some books or in objective type question you can see co-log of x equal to what guys? Minus log of x. Okay, so what actually here happening here, co-log means you have to take a reciprocal of argument. So reciprocal of x equal to 1 by x. Okay guys, already we have described the reciprocal questions in fraction. You can see the link is given in the description box. Okay, now so if we put here like this one, log 1 by x. Okay, so here log 1 minus log of x. Okay, one important thing you remember, log 1 or whose base is a may be 1 2 3 or root over 3 10, so its value will be always guys 0. Okay, so why this one 0? You can see the explanation how this will come. Okay, if we write like this one, so this one becomes 1. Okay, means base to power of 0. Okay, if it is like this one, suppose guys here 100 or 10 or this is 2, so what do in that case? This becomes 10 to power of 2, means the base is multiply itself by 2 times. Okay, so this is equal to 100. In this case 0 times, so we put the power of the base is 0, so this is 1. So this one explanation why we write log any base say b or 1, then this is equal to 0. Okay, now guys we had so many rules of logarithm here. Now see how could you apply these rules while solving the logarithm problem. Okay, see some examples here. First example guys, here log whose base is root over 3, then 4 plus log, or this is 27 2 by 3, or this is 25. So question is evaluate this one. Okay, now guys solution, here we can write log 4 whose base is root over 3 and plus log 25 base is 27 to the power of 2 by 3. So guys root over 3 means what we read in exponent lecture, this is equal to 3 to power of 1 by 2. Okay, and now guys 27 can be written as multiplication of 3 into 3 into 3, so this one becomes 3 to power of 3. So now we put these values in this question. Okay, so log 4 or this one 3 1 by 2 plus log 25 or this one 3 to power of 3 and multiply 2 by 3. So what we write next guys, here we can write log 4. Okay, now the base is 3, or now this power becomes 1 by 2 now. Okay, and this one log, or this 3 cancel out, 25 3 to power of 2 now. Okay, so this is 2 log here 3, and now this one guys 4. Okay, now we can write this one log, and this is 5 to power of 2, or this is 3 to power of 2. Then next one we can write 2 log 4 whose base is 3, this 2 okay come in coefficient and this 2 come in numerator. Okay, then this becomes 5 and log is 3, so this 2 and 2 cancel out. Okay, so next we can write 2 log of 4 whose base is 3 plus log 5 whose base is 3. Now we can next for solving write log 4 to power of 2 whose base is 3 plus log 5 and whose base is 3. Now you can see this one becomes 16, or this one becomes, guys, log 5 whose base is 3. Okay, now we approaches the reverse of our product rule, so this becomes 3, or we can write 16 into 5. So finally you can write it as a log of 80 whose base is 3. So this one is a solution for this question. Okay, now guys, you can see the next example. Okay, suppose a question is here given to you: evaluate value of x. Okay, here 2 to power of 4 plus ln x plus 2 to power of ln x equal to 136. Okay, so solution. Okay, so here base is 2, so can we add this one? No. Why? Here see the power is different. Okay, so what we can do next, we can write 2 to power of 4 into 2 to power of ln x. Okay, now you can write this one 2 ln x and 136. Here guys, ln, so we are not writing here, base is e. Okay, you know already this one is a natural logarithm whose base is e. Okay, now this becomes 16 into 2 power ln x plus 2 to power of ln x 136. Now guys, if we take 2 to power of ln x common, then this becomes 16 plus 1 136. Now this one becomes guys 17, or this is 136. So 2 to power ln x equal to 136 by 17. If you read the table of 17, then how many times it will come? 8 times. Okay, so this one becomes, guys, here 8. 8 can be written as 2 to power of 3. Now see, this base and this base is same, so it's now power or exponent must be same, so ln x equal to 3. Okay, now see, its base is now e because it is a natural logarithm. Okay, so finally what you can write, x equal to e to power of 3. Okay, so this is the solution for this question. Okay guys, whenever you see log is only written, so you can assume whose base is 10. Okay, this one is a important fact you always remember. So guys, you must remember, unless until it is not defined for base, so you can assume the base is 10. Okay, now see the another question. So question number now 3. You guys to solve 1 by log 4 whose base is 2 plus 1 log 4 whose base is 8 plus 1 log 4 whose base is 16. So solution guys, we can use here the change of base rule. Why? Because see here the argument is now here 4 4 4, so we can change all the bases equal to 4 first. Okay, because see here bases are different, 2 8 and 16. So we can write plus 1 log 4, this one divided by log of 8, and next guys we can write equal to this one 1 log 4, or this one divided by log 16. Okay guys, we can further write it as a 1 divided by log of 2 and then log of 4. Okay, this one plus sign. Okay, now 1, then again 1 divided by log of 8, and this is log of 4. Okay, so guys, we know we can write 1 divided by 1 log 2, and whose base is now 4, and again here 1 here divided by 1, or here log, here now base is 4, or this is equal to 8, then 1 by 1 log whose base is 4, and this is 16. Now next one, this one goes in numerator now. So now see, this is log 2 whose base is 4 plus log 8, then whose base is 4 log, then whose base is 4, and now it is 16. So guys, next we can write here log, here 2 into 8 into 16 whose base is 4. Now guys, we can further write it as a 4, or 4 to power of 4. So this one becomes 4. Okay, why? Because guys, here we uses the power rule, or now log 4 whose base is 4. So our answer is here now 4. So solution of this question is now 4. Okay, so guys, now see next example, fourth one. If log x whose base is a equal to 40 log x whose base is b, and this is 60, and you guys to find value of log whose base is ab and argument is x. Okay, so how can get the value of this one? Okay, so see his solution here. We can write log ab base and x. Okay, now apply here change of base rule. Okay, now this is equal to this one. Again it is becomes log of ab, then log of x. Okay, or you can further guys write it as a what here, 1 log a log of x plus log of b or by x. Actually what I am doing here, we expand here product of log ab. Okay, so we can write log a plus log of b, or again it is divided by log of x. Okay, now you can see we can write it as a 1 by log of x by log of a. Okay, and plus 1 this one, then log x and log of b. Now further you can write 1, this is now becomes log base a x, and this one guys plus 1 by log of bx. Now see, log ax and log bx is coming as per our question here. Now so we put the value, so we can write 1 divided by 1 by 40 plus 1 divided by 60. Okay, so guys, we can now take a LCM for 40 and 60. So this is 2 and this is 20, this is 30. Okay, you guys also see my previous lecture on LCM and SCF. The link is given below. If you get any difficulty for finding the LCM and how I am doing this work. Okay, so this LCM of 40 and 60 equal to 2 into 2 into 5 into 2 into 3. Finally what you will get, you will get 120. So we can write 1, then write 120 here. So 43 is a 120, so 3 will come, then plus, then 62 is 120, and then 1 is here, so you multiply by 1. So finally you can write this one 5 by 120. So 120 go in numerator, now this is becomes 5, so 1, this is 24. Okay, so answer for this question is here log of whose base is ab and x is argument, now this is 24. Okay, so this is the solution for this question. So guys, next we will see inverse of a function and inverse of a logarithm. Okay, see inverse of a function. Okay, so if guys fx equal to x to power of 4, or you guys to find f inverse of 16, then how could you find this one? So guys, here see this function fx is depend on variable x. Okay, so here x is known as domain. Okay, and the value we will get by putting the x. Okay, then it is known as range. Okay, see if suppose here x value lies like this one. Okay, so what will be the range of fx? Okay, so here minimum value of x will be 2, so we can write it as a 2 to power of 4, then this is 16, or this one guys here 4 to power of 4, this is 256. Okay, so this way guys, here domain means x is a now domain or range of this function fx. So this one is known as 16 and 256 range of this function. Okay, now come to our topic inverse of a function. So what we do, we can write y equal to fx. Okay, so y equal to x to power of 4. Now what we do next here, we take a power of 1 by 4, means multiply both side. Okay, so what you get here, this is x equal to y to power 1 by 4. Okay, now what we do next, we replace here x equal to f inverse of x and put y equal to x guys. Okay, so f inverse of x equal to here now x to power of 1 by 4. Okay, so next we guys write f inverse of 16, so we can write 16 or 1 by 4. So you know 16 can be written as 2 into 2 into 2 into 2, or now this is 2 to power of 4. So finally you can write f inverse of 16 equal to 2 to power of 4, or multiply 1 by 4. 4 cancel out, or this is equal to 2. So guys, inverse of f of 16 or x to power of 4 is guys 2. Okay, so this way inverse of a function is being calculated. Okay guys, now see how to find the inverse of a logarithm function. Okay, see here inverse of logarithm function. Okay, so if guys f of x equal to here log 2x minus 5 whose base is 3, and you guys to find out f inverse of 5, then how could you find this one? Okay, so its solution guys, first we write y equal to fx. Okay, now see y equal to log 2x minus 5, and this is 3. So our next motto is make this function of y. Okay, so and we can write next it as a 2x minus y here, or this is 3 to power of y. So we can write this one also. Okay. Now 2 of x equal to 3 to power of y plus 5. Okay. Already we read in linear equation of single variable. Okay. This one is known as a transposition. Okay. If you want to know about the more in transposition, so you can see that video, link is given in description box. Okay. Now then x equal to 3 to power of y plus 5 by 2. Okay. Now what you guys see, now the right hand side becomes a function of y. Okay. Now what we do next, we replace this one x equal to f inverse of x, and y we can replace by x. So next we can write f inverse of x. Okay, inverse means here we are putting a minus 1 sign of power of f. Okay, now this is equal to, now 3 to power of x plus 5 and now 2. So now see, now this function is becomes the function of again x. Okay. Okay, so f inverse of 5, now this is 3 to power of 5 plus here this one guys 5. Okay, or this one 2. Okay, so 3 to power of 5 here equal to 3 into 3 into 3 into 3 into 3 into 3. So this equal to 243. So we can put 243 plus 5 by 2, or this one equal to guys 248 by 2, or now 1, and this is equal to 124. Okay, so final solution of this question is 124. Okay, so guys, this is all about the logarithm. Okay, so you can say, sir, where we use the logarithm. Okay, so guys, when you solve some suppose here RC circuit in physics. Okay, now this one is a capacitor, or this one is a battery source E, this is a switch here, or this is R and this is C is capacitor, R resistance. So that time you can use the logarithm. Okay, now guys, hope this lecture is informative for you. So please like, subscribe and share to your friends this YouTube channel, which is Foundation JEE. Okay, now thank you very much. One more request guys, if you want to be updated for my next lecture, so please on your YouTube notification. Okay.